Hello everyone. So this will be our third video on C learning course. In this video, we are gonna see what are the no, this is not we are gonna see. This is completely from the last video. So I'm telling you what we are gonna do in this video. Introduction about classification. Then we are gonna see what was that data repression. Then we are gonna see the accuracy metrics and multi-output multi-label classification. I think this is it. Hmm. So this is related to the classification problem, and we are gonna see that to make out these things, we need to understand what is classification first. Okay. So in classification, we are gonna see that it is like a binary classification to identify digit 5. So it's like example. Let's say I have one column in which 5, 4, 3, 2, 1, 0, 5, 3, 1, 2. So these numbers are coming here in this column, and what I need to see, I need to make a classifier that whether this number will be 5 or non-5. So it will be 1, 0, 0, 0, 0, 1, 0, 0, 0. This is it we are gonna do. Right? This is a very basic classification problem in which we need to arrange numbers in a form of a class. So what we can do, we can create a different type of binary labels, and we can train this model on the basis of this, right? Train and test. We are gonna see that yeah, we can say these numbers are 5 and these are non-5. So there are many ways to do it. So we are gonna use stochastic gradient descent. In the next video, we are gonna discuss about this in more detail. But as of now, we can see that how these things work. So basically, there is a concept of learning steps in it, and whenever there are chances that we are near to the local minima, okay, so our learning step will increase, right? You can see once we are on the right direction, our learning steps will exponentially increase, and it will help us to reach out the convergence criteria. You can see there are two minima, local and global. Global is which you can say that if there are two threes minimas or available there, so minimum of the local minimas is known as global minima. So it's really efficient with the large data set. So why are we even using it? So we need to understand that how this classification method works. See, we know that the classification problem, we have some test and some we have prediction. And if this the difference between test and prediction is huge, which is known as loss function. Okay, we want to minimize this loss function. So wherever there are chances that it is giving the minimum of loss, it's a loss, right? And this is weights. Weights are giving to the different column, different attributes as per the, you can say, dependency on the you can say predicted values. We are gonna give these values of weight. Now see this white test and white bread. So it is getting you can say in a declining way. Okay, so we need to decrease, we need to minimize this loss function. So our loss function will minimize will on at this global minima, right? So first it will run for these values, then this iteration will be happen, and once we reach the minimum positions, so we can see that these weights are suitable for predicting the new outcomes. So this is what SGD used to do it. So in our problem, we are going to use SGD. So there are ways to implement it. Basically, we are using scikit library, sklearn library here, and it's having from the linear model, module, we are going to use SGD classifier. And simply we know very well, right? Train, and we need to use the fit function, or you can say fit method, to train these two data sets. That's it. And when we need to predict the new test data, we can use it. See, dot predict and some digit. If I'm putting some digit here, let's say if I am have giving 5 here, so it's saying true for 5 and false for 9, non 5. Now see there are chances of that we need to check the model accuracy, so we can do it right away. So there are cross validation and binary classification. So what is cross validation? So if I have you can say data in this form, 10 rows, okay, you can 4 5 6 7 8 9 10, okay, and I want to check the prediction on the in a very right manner. How can I do it? So what are we doing here in the cross validation binary classification? When I'm putting k is equal to 3, that means I'll you can say categorize this data into three subsets. Okay, and three will be like this, in which we are gonna predict accuracy for this set, then this, then this. If the accuracy is similar to, you can say very much similar, and there is no huge difference, we can say yes, model is doing its job perfectly fine. And this we can see that k-fold cross validation. If I can show you the initial results, let's say this from SQL, and there's a library already, model selection, we are importing cross validation score, and when we are predicting and we are checking for this model which we have created here, SGD classification CLF. So when we putting this model and putting X train Y train, CV is equal to C means that we are categorizing this data into three subsets, and we want to check the accuracy. So we are gonna very much similar aligning values, right? So accuracy we are getting 95%, seems impressive, right? But there is a catch here, which is goes like when I'm getting some dummy classifier, random classifier, and we are fit and predicting this value, again we are getting 90%. What is a dummy classifier? Basically, it is giving every value as non 5. So it is just giving every value non 5. That means if there is an 10 values of, if I'm giving 10 values, so every value it's giving non 5, non 5, non 5, non 5. Still, it is giving 90%. That means data is, you can say, imbalanced. So, so I think accuracy is not a right criteria to, you can say, saying that it's we can use it, right? There are many other things we need to consider, which are goes like this. We need to understand the confusion matrix. And now confusion matrix is meant for the classification problems. Okay, so there are four key metrics: true, positive, true, negative, false, positive, false, negatives. So predicted value will come into the row, and this you can say actual values will come here in the columns. Now it's saying test positive, test negative, has disease or no disease. So test positive means test outcome coming positive, means predictive value is saying it's positive and predictive value is saying negative. So when this test is saying that it's coming positive, when predicting test, we are saying that's positive, then positive will come here, but it's saying true. True means true and false meant for the real world application. You can understand like that. It's a real world. Test positive, positive, negative is meant for the test, means predicted value. So true positive means yes, it has decision. It said it is having test positive means it had disease. So it's a true positive. And no disease means false, but saying test positive, false positive. Again, it's saying no has disease, and it's saying test outcome negative. It's saying test outcome negative. So negative will be there, and has disease. Think true, negative. Okay, true, negative, false, positive. Let me check again. It should be true positive plus false positive plus false negative. Okay, so there are ways to create this confusion matrix. Confusion matrix by train simply we can get this value from matrix and we can create this confusion matrix through this method. I need to check this true positive is correct or not. True positive, false positive. Yeah, it's correct. Definitely it's correct. Negative, negative is correct. I think so. It should be. Hmm. So when there are positive, positive, it's true. When it's positive, negative, then it's false. Okay. And when there is a positive, negative, then it's false. Then negative, negative, that's true. Okay. So we can recall these values like this, that it's positive and positive, true. And negative, positive, there are, you can say, contradictory statements, so it's false, false, and this positive will come through the test positive, test negative. Hmm. So precision is true positive divided by true positive plus false positive. So true positive divided by false positive by true positive. Okay. And this false, there is just slight difference. We are considering false negative here in recall. False negative here. Not this, but this. And now why are we doing it's the accuracy positive prediction is the ratio of detected positive instance. It's the accuracy of positive predictions. There are positive and we need to check the what are the accuracy of these positive predictions. We are gonna make it. And ratio of detected positive instance means what is the ratio that it's giving the positive value. Now we need to understand the physical significance. So precision means the art of accuracy and the recall means the art of completeness. Real when our model predicts positive, how often is it right? 83 pins. High precision means low false positive rates. Definitely. Critical in cases where false positives are costly. Medical claims avoiding unnecessary treatments. Spam prevent illegitimate emails from being blocked. Out of all positives, how many did we catch? High recall means low false negatives. False negative means our test is saying, let's say, positive. Okay. And that means, no. The real ground value is saying negative. It's saying negative. And it's saying negative and it is having positive ground truth. So it will give us false, negative. Okay. So that means cancer detection. So means if if person having the cancer, that means having positive, but the test is predicting negative. So it's very we can't afford, right? Fraud detection. So it means out of all positive, actual positive, how many did we catch? So it's having formula true positive divided by true positive plus false negative. If having out of all positive, how many did we catch? It should be less. If it is zero, that means it is considering 100%. And while in precision, we are catching true positive divided by true positive plus false positive. Out of all positive instances, how many we are predicting correct? And in this scenario, we are predicting out of all actual positive, how many did we catch? So it's a complete chaos between these two. Precision and recall often have an inverse relationship. Spam filter. High precision, fewer legitimate email mark as spam. catches more actual spam but might flag some legitimate emails. If we are considering high recall, that means it's false negative will getting less instance, right? Will get less value. But we can have a chance that we might flag some legitimate emails also. Fewer false alarms, but catches more accuracy, but may have more false alarms. Spam detection, product recommendation, content moderation. Disease, criminal. When there is a serious problem, we need to always prioritize recall, criminal identification, fraud detection, safety systems. No perfect balance depends on the use case. Consider cost of errors, false positive, wrong positive predictions. In actual, it was positive. Okay. In ground truth, it was positive, but our model is giving negative. So that means wrong positive predictions. Miss positive cases means it was giving negative and saying positive. There's a false negative. So there are chances that we can miss some positive cases also. So how these things work in decision threshold? Classifier computes a scores for each star decision threshold, determines classification. If score is greater than this, positive, otherwise negative. Using threshold, we can understand that precision 80% for correct 5s out of 5 predictions. Okay, so it made some 5 prediction, 4 was correct, but 4 detected 5s out of 6 total 5s. That means out of total, you can say detected 5s out of 6 total 5s. Okay, in this scenario, 4, 5, 6, 7, 8, 9, 10. I think this is not used to be, this is different. Hmm. Threshold 1. So threshold 1 is here till now, till this. Okay. So now we can see that in this scenario, low, high, for correct out of 5 prediction, it is precision, and for rejected 5s out of 6 total 5s. For rejected 5s out of 6 total 5s. Hmm. Okay, so this same thing is mentioned here that precision 100%, 3 correct 5s out of 3 prediction. So we are already checking this thing in the predictions, but it is checking 50% recall because we 3 detected 5s out of 6 total 5s. Prediction precision means out of the predicted value. Recall means total values available in the data set. So if I can tell you that precision means that if I'm predicting, I want to check how well it is, right? And recall means I don't want to miss any chances of losing it. So this is what recall is capturing. High threshold, high precision, lower recall. Lower threshold means lower precision, high recall. Choose based on the error made costly for our application. Again, and I already told you, but this is ROC curve. ROC is like you can say is another metrics to check our accuracy metrics. You can say it's a part of accuracy metrics. And we have in x-axis we have false positive rate, and y-axis we have true positive rate. So that means positive means that basically we have false positive divided by total negative, and true positive means total true positive divided by total positives. So it's known as recall. There is a perfect classifier curve passes through 0, 1. Random classifier diagonal line. And practical models curve between perfect and random. In reality, it will be between these two only. So this is it. So this is ROC curve in reality. Random classifier. I told you that it's a random classifier. It's a equal trade-off between TPR and FR diagonal line. But in actually, it will more like this. True positive rate recall versus false positive rate. False positive rate is false positive divided by total negatives. And true positive means true positive divided by total positives. Visualize the classifier performance all threshold independent of class imbalance, right? And it will catch the real positives, sensitivity, and specificity, avoiding false. So we will we have a plan that it should be between these, and our curve will be more aligned towards this y-axis, top left, you can say. Closer to top left corner, better performance. Medical testing balance between false alarm and mixed cases. And we want to check the balance between security and usability. So it's basically depends upon multiple factors. The cost of false positive, cost of false negative, business requirement and all. There are another one, AUC, area under the curve, I think. Yeah. So ROC, AUC curve, we simply that if it is one perfect classification, 0.5 random, generally considered good, good exceptional. So when to use ROC versus PR curves. ROC curve prefer when balanced data set, false negative and positives equally important. And PR curves is a precision recall curve, you can say. It's imbalanced data set, true positive, and you can say they are focus on false positive more. Then we are going to use precision recall. Metrics that serve different purpose. Let me explain the key difference. ROC means that true positive rate versus false positive rate. I already told you true positive rate divided versus false positive rate. So true positive rate means recall, which is our sensitivity, right? Yeah, it's a sensitivity, and specificity is our false positive rate, and performance across all threshold values, how well model ranks predictions. This is it. And next thing is that to use AUC ROC when classes are roughly balanced, and PR curves are generally used when classes are imbalanced. Multi-class classification. Until now, we have seen only binary classification, but there are chances that we need to break multi-classes also. So it is like this, that a medical system, a diagnosis system that can identify different types of skin condition from images. It can be, you can say, any skin problem, right? Skin problem, acne, or there are multiples, right? Only single image. Human brain analogy significance is like the human brain analogy. Our brain naturally perform multi-class classification. So when we see a fruit, we don't just decide apple versus not apple. We can distinguish between apple, orange, bananas, etc. Right? Definitely, this is how it works. So how is the two main strategies, one versus rest and one versus one. So if I have given these, each expert focus on a different one specific class. Okay. So let's say 0, 1, 2, 3, 4, 5. So when I'm checking 0, this value, I'm comparing this with all values available in the data set. Then I will predict the accuracy of all, means the more weightage towards which number. Let's say point 0.8, point 0.2, point 0.1, and so on. Whichever having the most, you can say weight. I'm giving this value, or you can say giving the class based on that. One versus one physical energy or tournament bracket duels between each case. So what I'm gonna do, 0-1, 0-2, 0-3, 0-4, and so on. Whichever having the most, I'm considering that only. And then in the end, if 0-1 having, you can say, more alignment, more similarity index, in the end I'm just considering that only. So whoever is winning the most competition. So let's say 0 1, 0 1, 0 2, 0 1, 1 2. Again, for this number 0, I'm just doing 0 1, 0 1, then 0 2, 0 0 0. So that means it won 9 times. Okay, now next time I'm going to check for the 1. 1 2, 1 1 3, 3 1 4. Matlab means random. It will be all random. But which having the most wins, it will be 9, which is win by 0. That's how it works. It definitely is a time consuming. I already told you about this thing, the practical application. So we have a toy dataset, which is very popular, MNIST digit recognition. So it having the image data of 0 to 9 numerals, and we can simply find out the, you can say, very easy to make it. Okay, so now we are gonna do error analysis. No, not all errors are created equal. Understanding error patterns and helps target a medical diagnosis system that confuses similar condition need different improvement. And you can say like this that we need to understand where are we lacking in the modeling, because confusion matrix is all about giving some scenarios, but it is up to us that in which problem you can say what is helping us or not. It is up to us. There are variety ways to do it, right? Confusion matrix is one of them. So if I am having the 1,000 email classifieds, and confusion matrix reveals that 20 spam emails marked as important, 5 important email marked as spam. So in simple visualization, I can check this all information. Another one is cluster analysis, looking for group of similar mistake. Example, voice recognition system, many errors with background noise, few errors in quiet environments, and solution improve noise filtering. Examining errors across different features. A practical way is data collection phase, means we can create a log files. Visualization phase, which is confusion matrix, one of them. And we can do random things, means we can do work on the nuclear when there are random errors, systematic error, and edge cases. So there are different type of errors already available in the model. The pattern is systematic, then we need to add more relevant training data. Increase model complexity of feature engineering, definitely we can do it. And errors in rare but important scenarios, edge cases, it is getting failed, but if we can target the data collection and weighted training, definitely we can solve it. So this is for the multi output. No, no, this is for multi classification. So 0, 1. So this number can be from 0 to 9, anything, right? So this was for the multi-class. Now it is about multi-label. Now what is gonna happen here? Unlike traditional classroom where each item belongs to one class, items can belong to multiple class. So let's say apple. Apple can be red and fruit. These two classes. It can be red and fruit. And let's say what is that? TV, black and electronics. These two. These two label can be arranged, right? So it is giving true, true, false. For diabetes as for single patient, it is saying diabetes yes, hypertension yes, but asthma no. Similarly, label imbalance is one of the challenges. I already told you label correlation is one of the challenges. Missing labels is one of the challenges. So it's all about the EDA part. You can check very easily that what are we lagging behind, and we need to work on which aspect of the data sets which can be easily solved out. And this is about multi-output. So each instance can have multiple outputs. For example, if I'm saying temperature, I'm giving three, right? Temperature, but in temperature also I can have multiple classes. Cold, mild, hot, right? And precipitation, none, rain, snow, wind. So each instance can have multiple values. So multiple sensors, multiple predictions, cooler air quality and all noise levels. So I have told you about multi-class. Each instance can have only you can say one class out of one data set. One, okay. Multiple label is like this that a value can have multiple values, and multi output is that basically this also can have multiple values. Okay, so this is it about classification. Now we are gonna check some do some uh, now practical work, and we are building new model. As I will pick only this MNIST model data set for the practical purpose also right now. So let's do it. Okay, let's do the practical aspect of the classification modeling. So I will import the necessary libraries, making the code from sklearn. I need data sets, so I'm importing fetch OpenML to import the uh, you can say dataset, MNIST datasets, and I will require model selection, import train test, and also I will require pre-processing for standard scale out, import standard scalar, and I will also need a sample model, import random forest. Till now I need this only these things, so I will download this data. Shift plus tab to see what are the different parameters it will require. Hmm, I need to check the different it is giving me right now. I need to check report MNIST. Okay, so I can see here. MNIST should be here. There, I think they have changed the name. I'm just checking this. Okay, I got it. It is downloading. Let me check how is it looking. Data, data, data. So how many keys are there? Data, target, and all. Okay. MNIST dot target. So I have 70,000 rows and it is giving 543 based on the data, and data is like what is that? What is the shape of this data? 784s. Okay, 784 rows. Let me check the image data. How is it looking? Done. Data 0. Gray I am gonna use. It doesn't exist. Okay. So it will have 784 column. The Y should be its target. I need to split this data. White test. Xtrain dot shape and xtest. Done. What it will require apart from this, I give an X array like. Let me check. This is a type of data frame. So I need to convert this into array. Need to define the array. Yes, array class, or I can do like this also. Need to check how to import this to see this value. So MNIST data set OpenML. So it is good habit. This is their library. I don't know how to fetch it, so it is good to check the documentation. It's completely normal. This is done. This is done. Data I already pulled out. X train 0. I'm pulling out. I need to reset it. Yeah, this I was missing. Dot reset 28, comma 28, and I want to check the first image again. I'm missing something maybe. Where is X? Where is the X? Yeah, here it is. X comma 0 is not coming. What is this X? It's a data frame, right? Not a import without array. Oh. So basically this was data frame. I need to convert this into array. That's how it's working now. You can see. Don't require. So data is like this. And if I want to check for y0, right? So this is what has been given to me. Let me add one more cell here. If I'm not doing this thing, let me give. It will throw me. No, it will throw me an error that this 1D data is not allowed for image data. It need 2D array. 1D array is not possible because image is in 2D, right? So if I want to show it in, I need to do it like reshape. And 784, how can I do it? 784 can be bifurcated like this only, 28 by 28 pixels. Now if I want to see that y0 is given, right? So this is done, x is done. Let me show it some more example. 3. It should be 1 or 7. 1. Similarly for checking for 9, it should be 4. Yes, they are given this 4. So I have split this data. Shape is already given. Random state, let me change it. And the split size or size simply, what is that? Train size. Yeah, train size should be 28. Now it will be changed. Done. Trend is done. Image we have seen. Now we need to fit this model. So I'm calling this model is equal to random forest classifier. It will ask some parameters. So by default, an estimate will be 100 and all. So we will keep it as it is right now. No change. Before going for the fit transform, I need to why. So I need to scaling this thing standard scale out. I'm gonna use it. So X scaled scaled equal to need to call it scalar standard scalar dot fit transform. Then array scalar is equal to scalar dot transform. Done. Now we will fit this model training, model dot fit x train scale y train model dot predict uh, model dot predict test text scaled. Now it's working. It will take some more time. Okay, done. Model is predict. It is also done. Let me rerun. So if I want to check how is it looking, 4 1 2 3 4, and y test is looking like this, 4 1 2 4 5. Let me check some more examples. plt.im show. Okay, so I am pulling out some scale. Get alt.show. It's saying 44, and what we have predict for 0, we have predicted 4. That's nice. Let's check some more examples. Okay, so it's 6. It should be 6, right? It is 6. So we have pull out some data sets. We use standard scaling. Then we have trained this data set. We have an array. I convert this data in data frame into array. So it's giving me shape of, if I want to check the shape of this array, it should be a dot shape. A dot shape. It is 7,784, 7,000 rows and 784 columns. It's a 2D array. If I want to reshape, I can do, but why do I need to do it? Right? Now let's check more visualization here. Confusion matrix, we are gonna make it. Before do it, we need to, I think I should rename it matrix. So from SQL to matrix import accuracy. Uh, from SQL accuracy score, is it? Yeah, and accuracy score y test y pred is equal to 96.86%. Not bad. Let me put confusion matrix also. Confusion matrix and CM is equal to confusion matrix y test y pred, and if I want to check this, where I want to visualize this, first let's check this and then import seaborn as SNS and SNS dot heatmap CM uh, PLT dot. So I want to do it like this, annotation is equal to true. Okay. What are the